Good afternoon, students. This is a nodal analysis, one just like your lab. Because we're doing nodal analysis, we're solving for voltage. We want current source in the circuit. So what we're going to do is going to do a source conversion with the 6 volts and the 2K, and the 10 volts and the 2.5K. Remember that voltage in series is the same as current in parallel. So that's what we're going to do. We're going to do a source conversion here and here. So if we have 6 volts divided by 2K, we're going to get 3 milliamps. So we put that current, because if we slid this voltage down, the current would actually be going in this direction of 3 milliamps. And parallel with 2K ohm resistor. Remember, when we do a source conversion, this is the equivalent of this. This could be turned into this, and this could be turned into this. Okay, the next one we're going to do is 10 volts divided by 2.5K ohms. And we're going to get 4 milliamps. So now we put this next resistor in parallel. So we will have a 2.5K ohm resistor in parallel with the current. The voltage is going up, so the current source will be going up in that direction. It's going to be 4 milliamps. And then we have this last, pretend like we're just sliding this 3K resistor over, and then this is in parallel as well. So we have 3K ohms. Remember, with nodal analysis, it has to be at least 2 or 3 or more nodes. Well, these are all connected together, so we actually are only solving for one node, and we're going to call this V1. And then we have our reference node as normal. Reference node. Reference node. Okay, so normally we put the currents top to bottom or left to right. So this is going to be I1. This is going to be I2. And this is going to be I3. The next thing we do is define our currents. We're going to call this node V1. So we're going to define currents. We're going to define I1 as V1 divided by 2K ohms. That's defining this one. And we're going to define I2, which is V1 divided by 2.5K ohms. The last one we're going to define is I3, and it's going to be V1 divided by 3K ohms. Now that we've defined our three currents, we write our equations. What is leaving this node equals what is entering this node. So, looking at just this node, what's leaving this node? Well, you could say I1 is leaving, plus I2 is leaving, plus I3 is leaving, plus 3 milliamps is leaving, equals what is entering this node. So what's going into that area? The only thing I see is 4 milliamps. So 4 milliamps. Remember, when we write our equations, we're going to put I1, I2, I3 equals the current. So this 3 milliamps is actually going on the other side of the equation, so you must subtract 3 milliamps. Remember, what you do to one side, you must do to the other side. So you're going to subtract 3 milliamps. Goes here until you're left with 1 milliamp. So now you have I1 plus I2 plus I3 equals 1 milliamp. That's our equation. So now we have to substitute what we've defined as I1, which is V1 over 2K, and I2 as such, and I3. We're just substituting them. So I1 is now V1 over 2K ohms, plus I2, which is V1 over 2.5 k ohms plus I3, which is V1 over 3 k ohms, equals 1 milliamp. Now we just put all the V1s. If we had another node, we would put the V1s together and the V2s. There's only one node, so it's going to be 1 over 2k ohms plus 1 over 2.5 k ohms plus 1 over 3 k ohms. All of that is V1 equals 1 milliamp. And this is our one equation. Because there's only one equation, one unknown, we cannot put it into our calculator as simultaneous equations. We'll have to do this mathematically. See you on the next video.